How to determine gear ratio. In mechanical engineering, a gear ratio is a direct measure of the ratio of the rotational speeds of two or more interlocking gears. As a general rule, when dealing with two gears, if the drive gear, the one directly receiving rotational force from the engine, motor, etc., is bigger than the driven gear, the latter will turn more quickly, and vice versa. We can express this basic concept with the formula gear ratio equals T2, T1, where T1 is the number of teeth on the first gear and T2 is the number of teeth on the second. 1. Method 1 of 2. Finding the gear ratio of a gear train. 2 gears. 1. Start with a 2-gear train. To be able to determine a gear ratio, you must have at least 2 gears engaged with each other. This is called a gear train. Usually, the first gear is a drive gear, attached to the motor shaft, and the second is a driven gear, attached to the load shaft. There may also be any number of gears between these two to transmit power from the drive gear to the driven gear. These are called idler gears. 2. For now, let's look at a gear train with only 2 gears in it. To be able to find a gear ratio, these gears have to be interacting with each other. In other words, their teeth need to be meshed and one should be turning the other. For example purposes, let's say that you have one small drive gear, gear 1, turning a larger driven gear, gear 2. 2. Count the number of teeth on the drive gear. One simple way to find the gear ratio between two interlocking gears is to compare the number of teeth, the little peg-like protrusions at the edge of the wheel, that they both have. Start by determining how many teeth are on the drive gear. You can do this by counting manually or, sometimes, by checking for this information labeled on the gear itself. 3. For example purposes, let's say that the smaller drive gear in our system has 20 teeth. 3. Count the number of teeth on the driven gear. Next, determine how many teeth are on the driven gear exactly as you did before for the drive gear. Let's say that, in our example, the driven gear has 30 teeth. 4. Divide one teeth count by the other. Now that you know how many teeth are on each gear, you can find the gear ratio relatively simply. Divide the driven gear teeth by the drive gear teeth. Depending on your assignment, you may write your answer as a decimal, a fraction, or in ratio form, i.e., x, y. 4. In our example, dividing the 30 teeth of the driven gear by the 20 teeth of the drive gear gets us 30/20 equals 1.5. We can also write this as 3/2 are 1.5, 1, etc. What this gear ratio means is that the smaller driver gear must turn 1.5 times to get the larger driven gear to make one complete turn. This makes sense, since the driven gear is bigger. It will turn more slowly. 5. More than 2 gears. 1. Start with a gear train of more than 2 gears. As its name suggests, a gear train can also be made from a long sequence of gears, not just a single driver gear and a single driven gear. In these cases, the first gear remains the driver gear, the last gear remains the driven gear, and the ones in the middle become idler gears. These are often used to change the direction of rotation or to connect two gears when direct gearing would make them unwieldy or not readily available. 6. Let's say for example purposes that the 2-gear train described above is now driven by a small 7-toothed gear. In this case, the 30-toothed gear remains the driven gear and the 20-toothed gear, which was the driver before, is now an idler gear. 2. Divide the teeth numbers of the drive and driven gears. The important thing to remember when dealing with gear trains with more than 2 gears is that only the driver and driven gears, usually the first and last ones, matter. In other words, the idler gears don't affect the gear ratio of the overall train at all. When you've identified your driver gear and your driven gear, you can find the gear ratio exactly as before. In our example, we would find the gear ratio by dividing the 30 teeth of the driven gear by the 7 teeth of our new driver. 37ths equals about 4.3, or 4.31, etc. This means that the driver gear has to turn about 4.3 times to get the much larger driven gear to turn once. 3. If desired, find the gear ratios for the intermediate gears. You can find the gear ratios involving the idler gears as well. And you may want to in certain situations. In these cases, start from the drive gear and work toward the load gear. Treat the preceding gear as if it were the drive gear as far as the next gear is concerned. Divide the number of teeth on each driven gear by the number of teeth on the drive gear for each interlocking set of gears to calculate the intermediate gear ratios. In our example, the intermediate gear ratios are 27ths equals 2.9 and 30/20ths equals 1.5. Note that neither of these are equal to the gear ratio for the entire train. 4.3. However, note also that 27ths times 30/20ths equals 4.3. In general, The intermediate gear ratios of a gear train will multiply together to equal the overall gear ratio. Method 2 of 2. Making ratio, speed calculations. 1. Find the rotational speed of your drive gear. Using the idea of gear ratios, it's easy to figure out how quickly a driven gear is rotating based on the input speed of the drive gear. To start, find the rotational speed of your drive gear. In most gear calculations, this is given in rotations per minute, RPM, though other units of velocity will also work. 7. For example, let's say that in the example gear train above with a 7-tooth driver gear and a 30-tooth driven gear, the drive gear is rotating at 130 RPMs. With this information, we'll find the speed of the driven gear in the next few steps. 2. Plug your information into the formula S1 times T1 equals S2 times T2. In this formula, S1 refers to the rotational speed of the drive gear, T1 refers to the teeth in the drive gear, and S2 and T2 to the speed and teeth of the driven gear. Fill in the variables until you have only one left undefined. Often, in these sorts of problems, you will be solving for S2, though it's perfectly possible to solve for any of the variables. In our example, plugging in the information we have, we get this: 130 RPM S times 7 equals S2 times 30. 3. Solve. Finding your remaining variable is a matter of basic algebra. Just simplify the rest of the equation and isolate the variable on one side of the equals sign and you will have your answer. Don't forget to label it with the correct units, you can lose points for this in schoolwork. In our example, we can solve like this: 130 RPM S times 7 equals S2 times 30. 910 equals S2 times 30. 910 30ths equals S2. 30.33 RPM S equals S2. In other words, if the drive gear spins at 130 RPMs, the driven gear will spin at 30.33 RPMs. This makes sense, since the driven gear is much bigger. It will spin much slower. Community Q&A. Question: if a 38-tooth gear running at 360 RPM is driving another gear at 144 RPM, what is the number of teeth on the driven gear? Community answer: T1 asterisk S1 equals S2 asterisk T2 where T1 equals number of teeth on the driver gear. S1 equals angular speed on the driver gear. T2 equals number of teeth on the driven gear and S2 equals angular speed on the driven gear. 38 teeth asterisk 360 RPM equals T2 asterisk 144 RPM. T2 equals 95 teeth on the driven gear. Question: how do I determine my gear ratio in my gearbox? Community answer: if you cannot see the gears, you can mark the shaft and the start point on the gearbox and count the number of times it revolves when you spin the other shaft one full rotation. Question: what is gear up and gear down? Community answer: gear up is when you drive a smaller gear with a larger gear, thus creating a faster RPM at the output but less torque. Gear down is to drive a larger gear with a smaller gear, creating a slower RPM at the output but more torque. Question: how is gear ratio related to a gear train? Community answer: the number of teeth on your drive gear and on your driven gear determines the speed of driven gear. Question: what is braking torque? Community answer: braking torque is the actual torque applied after all the engine inefficiencies, frictional torque, are removed from the torque the engine is calculated to produce, indicated torque. Question: how do I determine the speed ratio between two gears given the RPM of each? Community answer: simply divide the two numbers the same way you would if you had the number of teeth of each gear. Question: can we mesh a gear having 200 teeth with a 15-tooth gear? What is the affect of the gear ratio? Community answer: yes. For each 1 RPM of the 200-tooth gear, the 15-tooth gear does 13.33 RPM. Question: if the wheels are spinning at 500 RPM, what would be the gear ratio? Community answer: in order to answer this question, we need to know the drive shaft RPM. Once you know that, it's very simple math to determine the ratio. Question: how is the velocity of the gear ratio dependent on the radius of the gears? Community answer: for two gears to be driving, meshing against one another, they must have the same tooth design, pitch. So a gear with 80 teeth compared to a compatible gear with 100 teeth should have 80% of the diameter. Question: what is the connection between LPM and RPM? Community answer: liters per minute equals LPM, in terms of liquid. Rotations per minute equals RPM, in terms of solid parts. Video. Tips. The power needed to drive the load is geared up or down from the motor by the gear ratio. The motor must be sized to provide the power needed by the load after the gear ratio is taken into consideration. A geared-up system, where load RPM is greater than motor RPM, will require a motor that delivers optimal power at lower rotational speeds. To see the principles of gear ratio in action, take a ride on your bike. Notice that it is easiest to go up hills when you have a small gear in front and a big one in the back, while it's easier to turn the smaller gear with the leverage from your pedals. It takes many rotations to get your rear wheel to rotate compared to the gear settings you'd use for flat sections, making you go slower. A geared down system, where load RPM is less than motor RPM, will require a motor that delivers optimal power at higher rotational speeds. Related WikiHows. How to change the cabin air filter in a Toyota. How to change your air filter. How to recharge the air conditioner in a car. How to free a frozen parking brake. How to remove rust from a car. How to extend the life of your car. How to understand the basics of car maintenance. How to fix a locked steering wheel. How to fix your car's air conditioner. How to diagnose a non-working air conditioning in a car. How to fix a peeling clear coat on a car. How to open the hood of a vehicle. How to replace car keys. How to repair leather car seats. References. url://science.howstuffworks.com/transport/engines-equipment/gear-ratio2.htm url://sciencing.com/calculate-gear-ratio-6495601.html url:/www.say.org/binaries/content/assets/cm/content/learn/education/motortoycar-samplelessonplan.pdf url://sciencing.com/calculate-speed-ratio-7598425.html About this article. WikiHow is a wiki, similar to Wikipedia, which means that many of our articles are co-written by multiple authors. To create this article, 31 people, some anonymous, worked to edit and improve it over time. This article has been viewed 1,347,878 times. Co-authors, 31. Updated, October 16, 2019. Views, 1,347,878. Article rating, 84%, 134 votes. Categories, car maintenance and repair, cars and other vehicles. Article summary. In other languages. Reader success stories. MD. Marlo de Guzman. August 5, 2017. I am currently in school for my airframe and power plant licenses. And this helped me gain the confidence work more. Rated this article. More reader stories. Did this article help you? Yes, no.